What is isomerism?
Who can tell? Who can tell? If the cutting and stitching change, a shirt or a skirt can be made, though the cloth is just the same. Its shape can change along the way, just like carbon and hydrogen. When their positions rearrange, though the formula stays the same, their structure starts to change. Same molecular formula, but the structure may not stay. When a different form appears, those are isomers. We say, this is what we call isomerism. This is what we call isomerism. What is chain isomerism? Who can tell? Who can tell? If a road goes straight ahead, it may reach a village there. If it branches into pathways, many routes will then appear. Just like carbon chains that change, their shapes also rearrange. One goes straight along the way, one goes branches on display. This is called chain isomerism. C4H10 has two forms. Who can tell? Who can tell? Standing straight is N-butane, growing branches isobutane. Same formula in both of them, only shapes are different then. These are friends we proudly know. They are isomers. What is position isomerism? Who can tell? Who can tell? Study little, you may pass. Study well, you'll top the class. It's a story of position. Change the place and change the name. One butene is on one side, two butene is on the other side. Though they're closely related friends, their positions make the difference. This is called position isomerism. What is functional isomerism? Who can tell? Who can tell? Ethanol and ether, let's talk about them too. C2H6O is the formula for both. Alcohol on one side stands, ether on the other hand. When the functional group has changed, properties get rearranged. These are known as functional isomerism.
When cis and trans appear, do you know their category? A double bond will hold them tight, preventing free rotation.
If cis stays on one side, trans appears on the other side. The way they stand and differ
shows us an important lesson.
Geometrical isomerism. Geometrical isomerism.
What is optical isomerism?
Who can tell? Who can tell?
Like reflections in a mirror,
like the left hand and right hand,
though they look very similar.
They can never match exactly.
One cannot fit upon the other,
They're never superimposed.
like mirror image partners.
Standing side by side,
These are called
optical isomers. What makes carbon special? Who can tell? Who can tell? Carbon is a magic builder, joining with itself in chains, making four strong bonds around, creating many different forms through catenation power and tetravalency strength.
carbon makes isomers appear.
Carbon is the king.
The magical king.
Why do we need isomers?
What benefits do they bring?
Making useful medicines,
Improving fuels for daily use.
creating pleasant fragrances, discovering brand new materials. Even small changes can
Create very big effects.
teaching all the world
A wonderful lesson of science.
isomerism. Same formula,
But a different shade.
isomers are formed. Isomers are formed. Chain and position,
Functional groups.
cis and trans,
Optical too.
with carbon special powers.
What amazing magic happens.
Isomerism, isomerism.
Now we'll never forget it.
And we'll pass our exams too.
I believe all of you have learned many new things through this song. If that is the case, may I ask you a few questions? Here comes my first question. What is isomerism? And secondly, can you tell me the two isomers of C4H10? Next, can anyone explain what chain isomerism is? Let me ask one more. Can you give an example of position isomerism? Do you know what type of isomerism is shown by ethanol and dimethyl ether? Can anyone tell me which category cis-2-butene and trans-2-butene belong to? Let me ask one final question. Who knows what optical isomerism is? Raise your hand if you know the answer. Well, I think everyone has understood the concepts very clearly. If you would like more educational songs like this on any topic, just let me know, and I'll be happy to create them for you. With that, I'll conclude my words for today. This is your own Ivayan from Sindhorakuru. We'll meet again in the next song. Bye.